All right, geometry. Okay, so geometry, first lesson, start of the year. What do we have to start with now? What is geometry about? Geometry is about shapes. Okay, so you have to be able to describe, before you can do anything with it, you have to be able to describe what it is. So we have to know the names of all the parts of this triangle. Okay, we have to know how to describe the parts of a circle. We have to know how to describe the parts of an angle, which we'll get into. And once we know the language, the vocab to go with that, then we can move on to more interesting things. But this first lesson is a lot of vocab, and it goes throughout the entire year. So it's important you know it, important you do it right, and don't just gloss over it. Okay, so you should have this. It's a handout. Sometimes, not all the time, I'll give you a handout where you can just fill it in as we go. And it's kind of nice because you can just put it in your folder, keep it for your notes, and you look back on it for assignments, study for tests, stuff like that. All right, so where do we start? We got to start at a point. The most basic thing, a point indicates a single location. And at any point, pause the video because maybe I'll just show something on the board quickly and you don't have time to write it down. Maybe I'll just move on quickly. Just pause it whenever you need time to catch up, write something down, whatever you need. Okay? I won't always remind you. All right, so it's a single location. It has no size, and that's actually pretty important. So it has no size. And what I mean by that is I mean that it's infinitely small, okay? You could never measure it. It's just one location with no width. That's it, okay? Now, how do we describe it, okay? You do have to say point and then a capital letter. So in this case, if we said point A, well, point A would be if we were talking about this right here. That would be point A. You have a point, and then you have a capital letter next to it to label it, like so. Give you another example. If we had this here, okay, you would need to say that this is point B. All right, pretty straightforward. It's a point. You need to use a capital letter to identify it. Okay, next thing, line. A line is represented by a straight path that extends in two opposite directions without end, has no thickness. A line contains infinite points. On a line, it's not what you typically think. A lot of people get this wrong. It goes on forever, okay? It doesn't just go to a point and stop. It has to keep going past that, okay? So because it keeps going on forever, you can pick any points on the line to name it, okay? And there's infinite points, but typically there's only going to be one or two labeled on any line, okay? So there's two ways to name this. And usually method one is what most people use, but the book will kind of switch back and forth between the two ways. So you need to know both. All right, so the first way is two capital letters. Not one, not three, two. It has to be exactly two. And you need a symbol. You need this symbol right here. Okay? It's a line symbol, and I'll show you how we use it in a second. All right, second way is one, you could use one lowercase letter. And I should probably leave myself some room to write it. One lowercase letter. Okay, now we're going to draw a line. I'll show you both these methods so it makes a little more sense. But let's say I have this line right here. Now, a line does not stop. It goes on forever, okay? And there's another name for that if it stops. We'll do that later. But this is a line right here. In order to name it with method one, we need 2 points, 2 capital letters that are on the line. So let's say we have point A is right here and point B is right here on the line. There's infinitely many points. Typically only a couple will be labeled. That's what you use. So we would say that this is line AB, and you need this symbol above the two capital letters that you use. Okay, that's really important. If you don't have this line above, it means nothing. Well, it means something else, but we'll get to that later. But it doesn't mean line. Okay, so that's how you describe a line. 9 times out of 10, that's what you do. Sometimes, when they're feeling tricky, they will do a lowercase letter, usually where the arrow is, and it's not a point. Okay, it's describing the entire line itself. Now, this is a lowercase letter. It's cursive. It's a cursive L. All right, and I say that because they're going to use some cursive letters. It's still lowercase, just so it doesn't throw you off, okay? So if we use this, we have to say line and then the lowercase letter, okay? So if we're going to describe it this way, we would say line L, just like that, okay? And here, we don't have to say, with method 1, we don't have to say line because we have this symbol here. But there's no symbol with this one, so you have to say line L, or whatever this lowercase letter is here. Okay? 2 different methods. Number 1 is the go-to. Remember, 2 capital letters, 2 points is what you need. All right, so now let's look at a plane. Okay, for a plane, it's represented by a flat surface that extends without end and has no thickness. A plane contains infinitely many points. So, if we look at this smartboard here, if you imagine that each of these ends were extended out forever, this one extends out forever, this one extends up forever, this one extends forever, it's infinite, okay? So really, or an infinitely big smartboard, whatever you want to think of it as. Now, because it's not just a line which is going in 2 directions, going in every direction, it's really hard to name it. So we have 2 ways to do this as well. It's a little bit particular, but it's not too bad. So the first way is we use 3 capital letters. Once again, these capital letters are points. I say capital letters, but really it's describing a point on there. So I'll just make that clear. And we're going to say plane. Okay, you have to say plane. You can't just say the 3 points and call that good, okay? And I'll show you what that looks like in a second. For the second way, you're going to need 1 capital letter that is not a point. Usually it'll be in the corner. It'll usually be clear which one they're talking about, but we could use 1 capital letter. And this is not a point. That's important. If you use a point, you did it wrong. Okay, so here's what's going to happen, all right? You're going to be given a plane, and there's never really a good way to draw a plane. It usually comes out looking kind of funny. Let's say this is our plane. Let's just imagine that it goes off in each direction forever. And let's say we have 3 points here. Let's say we have point A, we have point B, and we have C. You might have more, but you need to just pick any 3. So option 1 is you could describe this by saying plane A, B, C. Just like that. There's no symbol. You just say plane. That is how you would describe it. Okay? Now, what they're going to do sometimes is they'll probably pick some random letter in the alphabet, let's say Q. And it's not going to have a point. It's usually going to be right in the corner. And you can also describe it by using this capital letter as long as it's not a point. Okay? So you could also say that this same shape is plane Q. Okay? So those are the 2 ways to describe it. Now I will say that option 1 for both these are the more common, but you gotta know both. Sometimes you won't be able to use one or the other. All right, let's look at collinear points. Collinear, it's got the word linear in there. It just means that it's any points that are on the same line. All right, got more space than we need there. But basically, they're on the same line. They're collinear. I don't know. How do they make that more simple? All right, so if you have a line, And let's say we have point C and point D. We would say, and let's say we have point E here. Let's say that C and D are collinear. Now, we can't say that these 3 points are collinear because you could never draw a line through all 3 of these points. So it has to be 2 points that you could draw a line through. Okay, hypothetically, you could draw a line through CE and say those are collinear, but based on the picture they're looking at here, they're talking about C and D. Okay, coplanar. Probably guessed this one. Points that lie, or points and lines that lie on the same plane. It's always kind of a pain drawing a plane. Yeah, that kind of rhymed. It's always kind of a pain because, I don't know, they always kind of look a little funky, but do your best. Usually they draw a shape like this. Imagine that all these edges go out forever. Okay, so we could say that, let's say we got F, G, H, and I. Okay. We could say that points, and give myself some room here. Points F, G, H, and I are coplanar because they're on the same plane. Once again, draw it to the best of your ability. Now, we also could say this, okay? Let's say that I make a line like here and like here. Okay, I kind of missed the dot, but you can always make the dot bigger, and then it goes through the dot. Look at that. All right, so now we have 2 lines, and we have to imagine that this plane extends out forever. So these lines would also be on the plane forever if you extend out infinitely. So we can also say, and we don't have to say line because we can use this symbol here. We can say that, and I might just write this over here so I have more space. We can say that FH, so line FH and line GI are, you guessed it, coplanar. Okay, remember how to name a line? Typically this is how they're going to describe it, like I said before. All right, space. Now we don't use this too much, but essentially space is an infinite 3-dimensional area, right? So if you took this classroom and you pushed that wall out infinitely, you push this wall out infinitely, it's just like an infinite space, infinite 3-dimensional area, okay? Infinite 3-dimensional area. Okay? We don't use that too much. Mainly we just stay in 2 dimensions on a flat plane. But yeah, okay, so now we're gonna do some of these, and I want you to try to think of some on your own, but you can just keep listening if you want. If you want to pause it and try to think of it on your own, that usually helps. See if you're getting it. All right, so what are 2 other ways to name QT? Now, for a line, right, we got this line right here. You really just need 2 points, okay? Or a lowercase letter, hint, hint. So if we have QT, what are 2 other points, and you could use these again, that we could describe this with? Okay, think of it. Well, we use Q and T, we could use Q and N is also on this line. So we could do QN. Make sure you use your line symbol. We could also do T and N. And they have this lowercase m here. So we also could call this, so there's more than two ways, line M. And we have to say line because it's not 2 points with this symbol, it's just using the lowercase letter. Okay, good. What are two other ways to name plane P? All right, so plane P, they're using this capital letter that's not a point. So the other ways we have to use 3 capital letters, okay? So think of ways we could do that. All right, so we're gonna have to say plane because there's not a symbol for this, so we have to say plane. We're just gonna pick any 3 points that are on this plane. Now it's hard to tell from this picture, but it's intended that this plane is like this, and we have line QT kind of going through it from the top and then passing below it. So it's intended that T and N are not on the plane. Like I said, planes are kind of difficult to draw, but you just have to imagine that T and N are off of the plane. All right, so we just got to use these 4 points here. So we could say RVQ. So we could say RVQ. We could say plane. Or what did we already do? We could do RSV. And so on. Now, I just realized something I forgot to mention earlier. It is important that you pick 3 points that are not collinear, non-collinear points. Because otherwise you're just describing a line, right? So we would not say RQS because that could also be describing a different plane because they're all on the same line, okay? So we should probably fix something here. And we should go back to plane. And we should label this and say that they are non-collinear. All right, which we did do because A, B, and C are not on the same line, they're not collinear. So we have to make sure that when we name it, they're non-collinear. You typically run into that, but it is an important caveat. Okay, now there are other ways to name this. We're just going to move on here. I think there's 4 ways total to name it. All right, we want to name 3 collinear points. We've got some options here. So if you want to write it down, see if you get it, you're there, okay? So we could do this line here. We could say points RQS. And you do want to separate them with a comma because they're separate points. Or we could say this line here going up and down, TQN. All right, now to name a point that is not coplanar with RS and V, I'll let you figure this one out. We mentioned this earlier. And there's 2 options. Okay, 1 point. Like I said, if you want to do it yourself, just pause the video. We could either say point T, which is not on the plane, or we could say point N. All right, everyone's fine. They only want 1, you don't have to write both, okay? So I think, oh no, there's a backside, all right. So flip it over to the backside. Okay, we gotta talk about segments. All right, segment. Part of a line that consists of 2 endpoints. And every point in between. Okay, so let's do a picture here. And I'll explain how to name it first. So really what a segment is it's like if a line did not go on forever. We got 2 endpoints and everything in between. So let's see, we got E and we got F, and we put a point on the end because it does not keep going. Don't put an arrow, this is a segment. This is why people get confused when we say line. A lot of people think this is a line. No, this is a segment because it doesn't go on forever. Okay, we name it by its 2 endpoints. You do have to use a symbol, okay? So we have to say the two endpoints, E and F, and then this symbol for segment. It's just if you took the arrows off of a line. Okay, so that's our symbol. All right, array is part of a line that consists of one endpoint and every point in one direction. Okay, so similarly, it doesn't go on forever in both directions. It goes on forever in one direction. Okay, so let's say we have array G. Let's have an endpoint G here. Now, we need to name this with 2 points, okay, similar to a segment or a line. So typically what will happen is you'll be given a point somewhere on this ray, okay? Think of like rays of the sun, you know, they start at the sun and they shine out, so that's why they call it ray. Now, in order to name this, if you name it by its endpoint, G is our endpoint because that's where it stops, and another point on the ray, okay? It could be anywhere on it, call it H. Now, this is really important. The endpoint must come first. Basically, order matters. You cannot switch up the order, okay? Up until this point, I haven't really shown examples like this. Up until this point, you can switch up the orders of the capital letters and it doesn't matter, okay? Like this one here, okay? We could say EF or what? You know, probably think of it, FE. Same thing, because it does not matter the order. In this case, because it only goes in one direction, you do have to make sure the order stays the same. Start with the endpoint and then the other one. So this one would have to be GH. Okay, and there is a symbol with this one. It's like that, exactly what you think. Okay, it starts at G and it goes through H. So there's only an arrow on the right side there. Okay, you could not say, do not say HG. No, bad. Don't do that. No. Okay? All right. Opposite rays. What are opposite rays? Two rays that go in opposite directions. Okay, so we have two rays. So let's just do this. We have a point in the middle, and let's just call this point, I don't know, point C. All right, and going this way, we have a ray, and we'll call this point A. And so this is one ray. Now they're opposite because they go in exactly the opposite direction. So if you put them together, they make a line. So in this other direction, let's call this point B. We have another ray. So you can think of it like this. This is ray 1. And this is ray 2. Okay, together they make a line. Opposite rays make a line. Okay, maybe I'll write that here. They make a line. All right, so let's name both these rays. Remember, order does matter. So this bottom one here, this first ray, we have to start with the endpoint, or this point in the middle. Have to start with C, and it goes through A, so it'd be CA. All right, you can probably come up with the other one. Goes the other direction, starts at C and goes through B, so we have CB, an arrow like that. Okay, that's your two opposite rays. They make a line. Okay, almost done. Now, we need to name 3 line segments. Now you might say, why only see 2 line segments? Well, there is a third one, okay? I'll give you a second, name as many as you can, and we'll go through it. Okay, so we got the first one here, DE, and you need to label it correctly, so don't just right? DE, make sure you do a segment symbol. And then we have EF. And then if you put them both together, we have DF. Okay, that's a separate line segment. It's longer than the other two. DF. Okay, very good. Now, you might say, well, okay, what if I wrote DE and ED? Okay, DE and ED is the same thing, okay? You just switch the order. So it's not a different line segment. It's another way to name it, but it's not a different one. Name 4 rays. All right, so 4 rays. Okay, to start. So we got E to D. We got E to F. Order does matter. Make sure you don't mess up the order. Kind of tricky. You might say, how else can we name a ray? Because I need a point, right? If I go from F to the right, I need a point over here. I don't have one. Well, we're not just going to make one up. Let's use what we have. Well, you could start at F and go in the other direction, right? Because right now we have E to D. That's 1. We have E to F. That's 2. You could go F in this direction, so you get to pick, okay? You could do F goes through both of these, so we could just say F, E. That is different because the order does matter for these. It's going through, it's starting at F and going to the left when EF went the other direction. So we can say F to E. Well, I can probably tell you the last one here. Last one would be if we start at D and we go to the right. So we could say D to E or D to F. It's essentially the same thing. Okay? So because order matters, those are different rays because it tells you where it's starting at. All right. Got some postulates here. What is a postulate? Postulate is something that we know to be true and we have to rely on to move forward. Okay, they're pretty simple, so it doesn't take like Einstein to come up with these, but it's kind of something we have to all agree upon to move forward to more complicated things, more interesting things. All right, through any 2 points. If I draw 2 points, what could I make through these 2 points? There's exactly 1 line I could draw through any 2 points. Okay? There's not a second line. There's only 1 line I could do through these 2 points. Okay? Because the points are an exact location. There's no wiggle room. 1 line. Okay. If 2 lines intersect, they intersect at exactly, well, let's draw it out. I have line 1, line 2. What type of shape is the intersection of these lines? It's a point. So we can say that 2 lines intersect at exactly 1 point. Okay? That's right here. This point right here. If 2 distinct planes intersect, now they drew the picture for you because this would be impossible to draw. If 2 distinct planes intersect, they intersect at exactly, or inexactly. Let's look at the picture. It's easier because I have color here. But the intersection of these 2 planes is this right here. Okay? Now because the planes go on forever, so does the intersection, so we call this what? Called a line. 1 line. Okay, and we could name this one, it's line ST, just because I know this picture is kind of hard to see. Intersect at 1 line, in this case, that's ST. And through any 3 non-collinear points. Okay? Non-collinear is important. There is exactly what? So we can draw a picture here. If I have 3 non-collinear points, they do not make a line. What is the only shape that goes through all 3 of these? Well, that's exactly how we name a plane. So this is a plane is the only shape that can go through all of these, right? Because there's no line that goes through all 3 of these. 1 plane. All right, last thing. What is the intersection of plane CUE and EBT? Okay. Now, for those of you that haven't seen pictures like this before, you have to know what this is saying. This is a cube, or as close to a cube as you can get. And these dotted lines mean that they're behind the other faces of the shape, right? So like if you actually had this cube, you wouldn't see these lines because they're at the back of the shape. So really, this point H is on the front of the cube and point U is on the very back of the cube, okay? So let's think of it that way now. So if we have C, U, and E, plane C, U, and E, so C, U, E would contain this plane right here. That would be the bottom of the cube. And plane EBT, I'll do a different color. EBT, well those three describe this plane right here on the right side of the cube. What is the intersection of those two? We just said two planes intersect at a line, so which line intersects those two planes? Well, it'd be this one right here, blue here. It would be line EB. Okay, there you go. First lesson, a lot of vocab, hopefully it made sense. And that's it for this lesson.